Take it over.
Okay. Thanks, Leslie. My name is Jim Castaneri. I'm a geographer from the Denver office of the Census Bureau. I'm going to take some time today to talk about some new developments in census data and GIS. But I want to preface that first by saying, as a geographer, I deal a lot with desktop GIS, some with web-based GIS. But what I'm talking about today is a little bit above my head most of the time. So the perspective I'll be giving you is that from a layperson and what the potential I see for the future. I want to do a couple of little demonstrations of a new product called TIGERWeb and show you a little bit about the Census API. So let's see how this goes. And maybe I'll use this guy. Maybe I won't.
Okay. Sorry.
That's all right. So, traditionally speaking, when you have a desktop GIS and you want to integrate data with that desktop GIS, you have two sources of data that you need to worry about. Your geographic data and your GIS data, your demographic data and your GIS data. In the past, if you were doing some kind of demographic analysis, you had to manipulate those data sets separately and then join them with your desktop system. That was often a frustrating process, which I demonstrated yesterday if any of you attended the workshop we did on merging census data with Tiger data inside desktop GIS. Really today, in a nutshell, with this presentation really is about the fact that that process, I believe, is going away. Because of some new developments in web-based technologies, I think the future holds a brighter future for those of us who practice GIS. So let's see how many different buttons I can use to make the presentation today. So what's changed? Well, most significantly perhaps, and most of you, well, how many of you are GIS users? A lot of you, okay. How many of you have used web maps? If you're not a GIS user, you use web maps. Okay. It's pretty common these days with Google Maps and MapQuest and Microsoft Bing and all of that. A lot of those technologies are based on what's referred to as web mapping services, or a WMS. And if you're in the field of GIS, you know that web mapping services are based on a standard established by the Open Geospatial Consortium. And they sat down a number of years ago and said, there's this new technology out there that people have been working on, namely ESRI and others, who put webs on a map on the web, and they've come up with ways of making that work. It's now a standard, and you can actually publish different types of maps on the internet using a variety of different tools, and as long as you adhere to the OGC standard, then your product can be consumed by a variety of different software packages. One of the most powerful aspects of WMS is its ability to be read by a web browser. So Internet Explorer or Firefox can read a mapping service. And a good example of a web mapping service is Google Maps. MapQuest is another one. But other federal agencies also have them. The USGS has its own web mapping service. The Forest Service has it. The BLM has it. Many state governments, such as the state of Montana, they also have web mapping services that are available to the public. There's a product that we'll be demonstrating today called TIGERWeb. It's a census web mapping service that allows you to look at our Tiger data online in context. So if you're interested in the types of features that the Census Bureau tracks in our digital mapping database, TIGERWeb is a tool to allow you to see those map features. The important thing about a web mapping service is that the WMS is generated on the server side. The client has very little work to do to display a web mapping service. In fact, and I may be getting a bit ahead of myself here, a web mapping service is nothing but a bunch of little tiles, little pictures. And if you think of a ceramic tile floor, there are little tiles pre-established on the server that have pictures of the layer that you're interested in. And when you request a map, literally what the server does is send you little pieces of that map in the form of tiles for the zoom area that you're asking for. And if they're concerned about performance, they'll pre-cache those tiles, those little pictures ahead of time. And so there are set scales for all of the maps, and all of that information is set up front, cached, so that when you, in the case of Google Maps, for example, when you request a map of your town or your home, that information has been stored in a cache and it can come to you very quickly. And that's the beauty of a web mapping service. Similar to a web mapping service, but much more powerful, is a web feature service. Again, a WFS is established under the standards of the OpenGIS Consortium. And if you are a GIS user, a web feature service allows you to ingest over the internet actual primitives for the geographies in question. So the lines and the areas and the points that make up a map can be provided to you through a web feature service. Not only can it allow you to display the data, but you could also edit the data. And that's one of the more powerful functions of a web feature service. And we see a great potential for TIGERWeb in the future for a web feature service. Right now, TIGERWeb is only a web mapping service, not a WFS. So I'm at that stage in life where sometimes I need glasses and sometimes I don't. If I look there, I'm fine, right? Did I go backwards? No. Okay. So what else has changed? If you're familiar with census and census mapping technology, you've heard the term Tiger and Tigerline files. We have been releasing Tigerline files for over 20 years. And as a geographer doing GIS, that was a significant thing. Tiger being a digital map, if you will, in its most basic sense, really transfigured, what's my word here? Transformed, thank you. Yesterday was a very interesting day. It transformed the environment of GIS. Before Tiger came along, a lot of states and counties were building their own mapping systems, but there was no seamless extent to that data. The census came along in cooperation with USGS and built Tiger, a nationwide mapping system. It's really a statistical mapping system, so it's great for looking at the various data that are associated with Tiger that comes from the Census Bureau. So we've got Tigerline files that came out. You had to have software to ingest them into your desktop or your workstation. And then the Census Bureau said, oh, you know, everybody's using software that uses shape files, so why don't we just stop making Tigerline files that are text readable and very hard to process, and also quite large. Let's start issuing shape files. And a shape file is no longer a proprietary format, but an Esri design format for GIS data. And also the geodatabase is the same thing. And we actually decided, well, geodatabases are kind of a nice thing to have too. So just in the last year, we've also provided select Tiger data in geodatabase format. Again, these are Esri standards. That's in the industry we say Esri, the ESRI. A big GIS company out of Redlands, California, like the Microsoft of the world. So we started offering this data 20 years ago. It was on CD-ROM first, and then we put it up on the web, and now we're doing shapefiles in geodatabases. And within the last year, we've also put some shapefiles in geodatabases up there that contain a wee bit of the SF1 and the ACF 5-year data. What's SF1? That stands for Summary File 1, which is select data sets from the decennial census, the 10-year census that last occurred in 2010. And then the ACS 5-year data, that's the American Community Survey. The American Community Survey publishes a wide variety of data variables in a couple of different time spans: 1-year data, 3-year data, and 5-year data. So the 5-year data is what's being offered as pre-joined on our website with Tiger. It's not the only source of the data, and you probably are aware of that. It's important to note that the geodatabases contain metadata tables for the data that are inside there. And if you have worked with census demographic data, particularly the ACS, you know that finding out what a field name is and the definition of that can be a real pain in the neck. So it's nice that those geodatabases have metadata tables. There's one geodatabase in there that's got a geodatabase for each state that contains population and housing data to the block level. And if you're working at redistricting for the state, or look at rejiggering your school districts or your fire districts and those kinds of things, that data set would be real helpful for you. So I'm glossing over a lot of this stuff pretty quickly, and looking at the clock not quite quickly enough. There's a lot to say here, but let's get to some of the nitty-gritty. The API is a new release also in about the last year or so from the Census Bureau. API stands for Application Programming Interface. This is a series of tools, I'll put it that way, that reside on the Census Bureau servers that will reply to you if you send it the right kind of request. And if you're a programmer, I know some of you are developers out there, even though you won't admit to it, you really can send a specialized request to the Census Bureau server, and it'll respond with some specific information back to you. This is pretty cool, and I'm going to give you an example of that here in a minute. And those of you who play around in desktop systems where you process data, you'll start to see some real power in the new Census API. So TIGERWeb, there was a little history there. I talked about it. The Tiger line files. Really, TIGERWeb is the next evolution from a long progeny of Tiger-based files. I talked about Tiger line files, the shape files, geodatabases. TIGERWeb is that next evolution. If you just need to see the Tiger data and you don't really need to ingest it into your desktop, you can do that with TIGERWeb, and we're going to show you an application on that in a second here. So this is our TIGERWeb main page, and you can find it at tigerweb.geo.census.gov, and I've got the URL on here. On the next, did I have it? Yeah, I had it right there, tigerweb.geo.census.gov. If any of you have laptops that are in front of you and want to check it out, that's where you can go. So this is what the page looks like when you get there. I'll take just a minute to point some things out. These tabs along here describe different aspects of what TIGERWeb is and how you can use it. We have the web mapping service here under the WMS tab. Then the REST services. And REST is representative state transfer. And it's a relatively new way of having a server return very specific data elements to you based on criteria that you establish up front. And I want to demonstrate that to you. Under the data files, there are different descriptions to what is included in TIGERWeb, and then the geographies in TIGERWeb, and a contact us. There are two different versions here, and I'm going to point to it here, although it's not live. TIGERWeb is the current version of TIGERWeb, and we update it about twice a year using the most current geography at the Census Bureau. TIGERWeb 2010 is the census version of all of those geographies. So if you want to know what the place boundary for Helena looked like on Census Day, that would be the place to go to see that. So as I mentioned, it utilizes the REST protocol, and basically, you know, it's hard for me to explain what it is when I don't understand it very well myself, but demonstrating it, I think we'll all understand it a little bit better. there is a separate URL. If you know what a URL is, a universal resource locator. In the days of the internet, we are always typing http://www. Well, that's the URL, right? For TIGERWeb, there's a separate address for each service that we offer. And there are several dozen of them. There's a service for census blocks. There's a service for places. There's a service for census tracts. There's a service for hydrography, and on and on and on. And each one of those themes or layers in the talk of mappers has a unique URL to it. And if you send the right request to that URL, you'll get a map back. You can ingest TIGERWeb with your browser, and I'll show you that too. You can ingest it with a client such as Gaia, and that's a open source software tool. I don't know what the acronym stands for at the moment. But even Google Earth will consume a web mapping service. A lot of people don't know that, but if you're a Google Earth user and you haven't checked it out, it does pretty cool with web mapping services. And of course, desktop GIS will ingest a web mapping service. And just about everybody who's anybody that creates map products in the United States has a web mapping service with some kind of data associated with it. So let's have a look at TIGERWeb real quickly. This version of TIGERWeb uses a Silverlight plugin, a Microsoft Silverlight. There are lots of different ways you can use a mapping tool. You can use JavaScript. Silverlight's another one. There is, what's that other one? Escapes me at the moment.
Flash.
Flash, thank you. So what you got here is inside your web browser is a map. And this is not new to most of you, I'm sure, because you've seen these things before. Yet the technology behind it is only maybe 3 years old, with Silverlight being in the picture. So what I've got is a little layer legend that pops up here. And even though we're only worried about the United States, TIGERWeb pops open showing the entire world. And with a little roll of my mouse button, I can zoom in. I can click on this tool here and zoom in. Again, you probably have seen this before in other places. Esri is one company that implements the software, and we're actually using Esri software to do this. There are other software packages that will do the same kinds of things. There are even open source tools that will allow you to publish maps like this online. Open source meaning free with the code available. With this map layer legend, I can turn things on and off. It is scale dependent, meaning how far you're zoomed in or out will determine what you can and cannot see. So if you're trying to show census tracts and you click them and turn them on, you see the little, you go, well, nothing happened. It doesn't work. You're not at the right scale. So zoom in, and I'm really addicted to the mouse wheel, so I kind of have to have that mouse in hand for me to use it. You'll start to see some different things show up, and you have to be in the right county. The tracts require a minimum 2,400 people before you'll start to see the boundary. And there we go. I just wanted to show a tract number there. So that looks like Bozeman, huh? So you see the little tract numbers there, 1.02, 1.01. Those are census tracts. I can turn that off, and at this scale they'll disappear right away. I can turn on transportation, and this is all based on Tiger data. Everything you see, except for the shaded relief, is coming out of Tiger. So if I want to ingest this stuff, I can, using my own application at home. So this is a viewer that we have, TIGERWeb Viewer. And I can't spend much more time on this because I have more to cover. I'm just going to close Current tab. I want to talk with you about some other tools.
Quick question, Jim.
Yes, sir.
In the past, Tiger data has not lined up as well as we would like with other layers we've had. Has there been improvements to that?
There has been some improvement. When we were talking back in the back room here earlier this morning, Montana has probably the best track record of any state in the country when it comes to homegrown GIS. I don't mean to imply that it's, because it's homegrown, it's not sophisticated. It really is one of the most sophisticated data sets in the country. And Census, quite frankly, has had a hard time catching up with what Montana has been doing. A lot of great initiatives here at the state: boundaries, cadastral layer, addresses, and we recognize that work that's being done, and we are trying to work with Aaron and others at the state. We've had some success. Over the last 15 years, it's improved quite a bit, but you will still find some inconsistencies in places. And it has to do with our topological requirements in Tiger. We have a lot of relationships between aerial and linear features that say this particular drainage ditch is also relevant to voter district such and such. And in Tiger, everything is integrated as a single layer. We don't have separate layers. So when you make one change to one feature, it has a topological rule that requires another change to another feature. And that's a somewhat lengthy explanation of why it's fairly difficult for us to use individual layers from local governments, because we have to adjudicate differences when it gets integrated into Tiger. We hope, though, to provide a continuous process to the state of Montana and others whereby we can continue to receive those updates and Tiger can be improved continuously. That's our goal. I mentioned another software development, and this isn't outside of my realm as a geographer, so I'm quickly getting out of my comfort zone. The Census API is a really neat new development, in my opinion, for data users, demographic data users. So this is all about demographics. It's not about Tiger or mapping at all. It's all about the data. And being kind of a data nerd, I went to that website and I found out that to use it, you have to sign up for an API key. So it's this big old long string of characters that identifies you as a user. So if you want to use this, you get a sign up for key. It's free, but they'll send you the key and then you start using it when you start playing around with things. Right now, the API provides live access to select SF and ACS tables. You heard me use that before, so summary file and ACS. When I say select, it's a pretty good percentage of those two data sets are available through that API. It utilizes that REST protocol, and in my opinion, this is really the future for GIS data users. As we continue to expand the Census API, you'll see more and more variables from the Census available through the API, and I really think this manual process that I talked about yesterday is a bygone era. I think soon there'll be so many tools out there available to leverage that API. You'll simply click a few buttons in your desktop GIS and the variables you want will be brought to you in real time. So I'm going to give you a demo about that now. I should know that wouldn't happen, but we can still. Where was that HTML file?
I think if you just do IE down in the corner, isn't it? Don't we still have it open? Yeah. So, yeah.
Okay. So, I'm a nerd, not a hacker and not a programmer, but playing around enough with the tools that they provide you, one can put together a few things to play around with what the API does. So in order for that API to work, you have to send it some very specific requests. All of this is documented on that developer website. But I wanted to show you this because it really, by using this, you can see exactly what string it is you send to the server and get a real feel for how it works. So I'm going to go back and describe more of this in a minute, but let's run through it real quickly. I want to choose some 2011 5-year ACS data, and I threw some variables up here that I thought would be usable. Okay. So the part that I want you to look at right now is down here. And I'm going to explain this string for just a second, if I can, without getting in the way. So you see the HTTP api.census.gov/data. That's the parent URL, that's the location of the API. The rest of that long string are the criteria elements that give the server side the information it needs to return information to you. So this little slash here says I'm accessing 2011 data. Then I have a variable called ACS5, 5-year ACS data, and then there's my key that I applied for. Even though I'm an employee, I still need a key. That big old long string all the way to this ampersand is just says this is Jim using the system. And then the actual command here. I want this variable, B08301_001E, that's the estimate, and I want this variable, E, another estimate. And it turns out I had looked this stuff up before and made myself a list. I want means of transportation to work total, and then I want those that got to work via bicycle. You know, if I'm doing analysis, why might I have chosen those two? Because I want to normalize the data. I want to be able to see what percentage of cyclists there are for a particular area. Once I generate this long string, the last thing I do in my URL is say, what geography do I want? So it's really quite simple. All I'm saying is I want these two variables. I have to know what those variables are up front. So I've got to go into the documentation and say, I know what B08301 means. And if you know that, there's a table that we provide that you can look every variable up. It's a spreadsheet. You know ahead of time, you could simply build a lookup tool like I did here and say, put all 9,000 plus variables as a lookup tool. And you could search by keyword or whatever you want and pull up your variables and let the user select which ones you want. And then you add them to the list and it's separated by commas. So I want this variable, comma, and this variable. And then I want it for all counties in the United States. So that's all I've said right here. I've said, I'm Jim. I want this variable and that variable for all counties in the United States. So if I send that, if I post that request to the server, it's going to ask me, I want to open it. And I'm going to open it using Internet Explorer. This is what the result looks like. So it's a text formatted file that contains a header, and yesterday we talked about that as well. So it's a comma separated values. Actually, this is a JSON return, a Java standard formatted file. And you've got the square brackets in there and then some quotes, and then you've got that variable name that I asked for, B08301, comma, the next variable, the state and the county. And if you look at this, as from a GIS user's perspective, this is the header. This is your first data record. So this is the value for this field. And there's the value for that field. So this particular field, wow, count as state, county. Oh, this is, I'm sorry, I did the whole country. So this is Alabama 01? 01, 0001 County, Alabama, Ottumwa County maybe. So there were 24,349 people who commuted to work, and of those 12 rode bicycles. And there is my state FIPS and my county FIPS codes. So if I want to merge them into my GIS, I can do that. Before I do it, however, I've got to manipulate this file somewhat. But if I were a programmer, I would just write a little snippet of code that says, when this comes back to me, strip off the brackets, do this, format it this way, slap it right into my GIS. Which, you know, if you gave me a little bit more time, I might be able to do it myself even. It's that simple. So, if I were to change the data set, I won't flog the horse too long here. So I'm changing to SF1 data, and I build the URL for it. Again, I have the path or the server location where I'm sending the request. I'm now going to the 2010 SF1 data. Here's my key, it's me. Here's my variable. I want total pop. and total white alone for tracts in state 30, county 31. So you can see now how I'm requesting for a single county's worth of tract level data for these two variables. So unlike FactFinder and a lot of our other tools where it asks you lots of questions, what do you want for what geographies, this requires that you know up front the geography you want and the names of your variables. If you're going to do this a lot, or if you're building an app for somebody, which you might do, you're going to read all these variables in some place and have them as a lookup table. You're going to know some of the rules, like that you can't search for SF data in the ACS folder, those kinds of things. It's really quite simple. Once you build that string, you send it to the server takes a few seconds and dumps the data right back at you. And if your software on the end is ready for it, you can load it straight into a map immediately and never have to do a download at all. So, where were we here? Hopefully close to being done. I guess I wasn't that far along, was I? All right. Yeah, it was pretty close to being done. So, I believe this is the way things are going to work for GIS users in the future. I mentioned it before. When I first started playing around with it, I saw a lot of potential there. And again, not being a programmer, I played around with enough to see, boy, this could do quite a bit. I think we're going to start to see this more and more, where your application will ask the API for information. The API will send it to the application, and you'll never have to know what happened in the background. So custom applications in the future. I'm really looking forward to the day when someone writes a Python script so that in ArcGIS I can just put my variables in, it goes and grabs them and brings them back for the geography I want. And that's really all I had to talk about today. It was a fairly focused subject and not a lot of nitty-gritty, but are there any questions or comments?
Thank you.
Good, thank you very much.